ಯಾಕು ಕಾಲೇಜ್ ಇಲ್ಲ ನಿಂದು? Any doubt in yesterday's class? Any doubt in yesterday's class? No doubt. You don't have any doubt? Why? What we have to do today is, yesterday we have done turning on a LED and off an LED. All of you are clear with that? Any doubt in that? And I said like I was not clear about set bit and clear bit. We have done yesterday using move instruction. I will let the same program. You can write this program. It is the same program as we have written yesterday, but the only change is the instruction. Now you tell me, do you have any doubt in this program? Even if you don't write this, it is also okay. Because it is a continuation of this thing, like it will be after that. End should be? Yeah, this is the end. No. The call delay will go here, come back here. I have not tried. I should try that. I will listen. But logically, it is the end is this one because it will go here and come back from there. So end has to be here because once it returns from there, what is next? Once it returns from there, right? Somewhere end has to be there. I believe it is a logical end, but I will try it and let you know that. No, guys, whether end has to be here or here. Other instructions are ignored. Yeah, then like you have to put it there. I have not tried this, where the end has to be, but logically it has to be there. Right. What is the difference between yesterday's program and this program? Quickly. What is the difference between yesterday's program and this program? Yeah. No, that is delay thing, like we will take the delay part as a calculation thing. In here, what is the difference that you can see? That bit addressable, byte addressable accepted. Next. No, the same concept. Pin or bit are same concept. It's same. No separate. Like yesterday we have written this function, we felt like this delay is not enough, so increased it. That's all. No. We didn't initiate the port. Where we have initiated the port? We have not initiated the port in here. For that the reason is this. For P0 there is no pull-up resistor. Apart from that, like every other transistor has every other port has a pull-up resistor, right? If we want P0 to act as input-output port, we have to put a pull-up resistor for P0 also externally. This we have discussed. So that the final conclusion is that if you want to operate, send a signal out from the pin or receive a signal through that pin, you should and must have a pull-up resistor. P1, P2, P3 has internal pull-up resistor. P0 needs an external pull-up resistor. That's the discussion. Bye. This is only one part of the whole port, output part of the whole port. If you want, it is D flip-flop is here. Okay, we'll write that also. D Q bar is what we need, and then like for some there is a mux, for some port there is no mux. For P1 there is no mux, it's direct connection. Correct, right? Direct connection. Was that a direct connection? Direct connection. Right? Now what happens? See to this very carefully. When I do this, set bit 1.1. That means D will become 1. This D will make this as 0. This 0 will, then there is some mistake here. Is it port 1 is clear? Correct, right? Correct only. Sorry, it is right only. Port 1 is simple. This is 1. The Q bar is 0. As it is 0, this is off. That means this point is connected to this one. It is pulled up. So 1 will be here. Right? Now I will connect one switch externally. Let's say again this has a pull-up. This is a switch connection part. This is a switch connection part. Now if I make this switch on, connected, then what happens? Then what happens? The ground will pass to this. This will also get connected to ground. This will find its ground path. This will find its ground path. So on this pin, there will be 0. Why? Because this is giving that 0 connection. Is it clear? For this has to be 1. That is why we said if any pin has to be an input pin, or to convert any pin to an input pin, you should move A, hash 0FF H. This we have said it yesterday. If this by itself is 0, imagine now we have put 0 here, this 0 here, this is 1 here, that means this is 1, this is grounded now, this point is grounded now. This has no meaning. This has no meaning. The meaning is that there is an LED connected here which goes to the ground. It is off because this is 0. Move A, hash 00H will make the pin output pin. You are understanding this? When D is 1, this pin was acting as an input pin. When D is 0, this pin is acting as the output pin. Is it clear on this? Right? The other side of it. When we do the output, or when we do this A equal to 0FH and then we do move P1, A, right? We see it like first time when we do this, we are setting the port. We are setting the port. It is also true that we are outputting 1 here. We are setting the port, yes. We are setting the port, yes. It is also true that we are outputting 1. So by default, first time when we do it this way, port will set and output will be 1. Okay? Depending on your input from the external side, the port will take its decision. If it is 0, it is 0. If this is also 1, not connected, it is 1 always. Is it clear? Is this clear? Please write down this diagram. This, see, the dealing with the ports will give you a small confusion because there is a slight difference between the latch value and pin value. Latch value and pin value. So please write a switch here and write this value quickly. Now with this analysis, you should look at this now. Set bit 1.1. Please write this connection, only this connection. For port 1, this is a standard connection. We have written this when we have discussed the port 1 structure, internal structure. But writing a program, you have to have this in mind. Why I have to give this thing? Please write this properly, the switch connection. And below you have to mention one sentence. Written? This only this part, port 1 part. Okay? Right. Below that you mention a sentence. When we configure a port as input, by putting FFH to that port, we are also doing output at that pin, output on that port as FF. That is, it sets both latch value and pin value. Shall I repeat it? When we are configuring a port as an input port by putting FF to that particular port, we are also doing output at that port as FF. That is, it sets both latch and pin value as FF. Why is this again? Like, let us see. To output, this is a channel. Guys, let's see to this. How does you output some value? This is a channel. It has to go through the latch. What about input? Input, this is a channel. It does not link with the latch. But what is the point? The latch has to be 1. Okay, if latch is 0, this is 1, this is grounded. Whatever you do here, it is grounded. It has no meaning. Is it clear? The importance of writing a program lies in understanding the physical structure behind it. It is just not this thing. Why is this thing? Is because of this. Is there any doubt in this? Now you analyze with this set bit P1.1 with respect to this. Output channel mention. Output path or input path. Done? In that, like whatever we have written, it sets both pin value and the latch value as FF. There is one statement below, I will read it. If you feel it is worth to write, you write it. But when a value at the pin is 0, don't write it here, listen to me first. If you feel it is worth, you write it. But when the value at the pin is 0, then logically it cannot take any input. When the value at the pin is 0, that means this point is connected to ground. Logically it cannot take any input. Is it clear? That is a statement you have to conclude. Write it. When the value at pin is 0, when the value at pin is 0, then logically it cannot take any input. Hence, it is only output pin or port. Hence, it can be only output pin or port. Clear? What Akshay and this girl said. So please mention and here. Okay? We'll believe them. But however, I will test and let you know. I have not tried this. Right? Done? Okay. Is this clear with this? Now you understand the set bit 1.1. What happens? What happens? This D is 1. This D is 1. This is 0. That is why this pin is 1. We are outputting 1. Then what we do, we'll call a delay. This here. And then like clear pin 1.1, we'll put 0 here. As it is 0, this is 1. As this is 1, this is 1. This point and this point are same. We are outputting 0. Is it clear? And then what we do, call delay and just jump here. Now with this LED on and off, can you write a program to generate a square wave? You have written this program. You have written this program down there right now. Write an assembly program. Write an assembly program. Write an assembly program. Write an assembly program to generate the square wave. Square wave. It is the same program. This is the same program. We have connected LED. You can see that LED goes on and off. But what is the point in square wave? The on period and the off period has to be same. Right? Is it same? I don't see that. Do you see that? I see that 2 machine cycles are extra in the off cycle. Will you see? Are you seeing that? Only because of S jump here, it will take 2 machine cycle extra in the when it is in the off period, clear period, off period. When it is in the on period, the 2 machine cycles are less. That is only the problem. Otherwise, it looks same because 2 machine cycle is what is the difference? Around 2.16 microseconds is the difference. But when you use oscillator and see, right? You use oscillator and see in micro scale, then you can see this difference. Now, how do we eliminate that also? Where? Here. That is one simple thing. The other thing is what? I will write one program. You tell me like what it does. Anyway, this guy remains same. This delay is same for both of them. That's all is the program. What it does? By default, pin will be 1. We know this point, correct? Now what I am doing it as 0, call a delay, and I jump back here. Now again, like I will make that as 1, call a delay, and I jump here. This will generate a perfect square wave. Got the difference? Only these 3 lines you write and you justify that. That program you written that write a program to generate a square wave, only this part you write. And you should justify why is this is a perfect square wave and why not that. Yeah, we have 2 more important points to be discussed. Is it done? Is it done? You have to justify this. Write a statement below there. Why this is a perfect square wave? Why not this? You can say that like previous program also generate a square wave, but there are 2 machine cycle extra during the off period. Off period compared to on period. Clear? Right. Now you know what is the duty cycle. You know what is the duty cycle? Duty cycle is what? If this is one cycle. This is one cycle. This is on period. This is off period. What is the duty cycle? No, you cannot approximate it. What is the duty cycle definition? On divided by on plus off. On plus off will make one cycle. How much positive part is there in the total cycle is the duty cycle. On plus off is the duty cycle. If the duty cycle is 50%, that means it is a square wave. If duty cycle is 50%, that means positive part in the whole cycle is 50%. That means it is a square wave. Right? Now I want you to try this. You have written this. Duty cycle equal to on divided by on plus off, you have written. Write a program to generate 66% of duty cycle, generate a signal with 66% of duty cycle. 66% of duty cycle. How do you do it? Yeah, that's all. How is that like 2 times on you have decided? That's all. You understood the point? 66%, you calculate it, it will be 2 by 3. 2 in 3 parts if you divide the signal, and 2 times it is a positive cycle and 1 times it is a negative cycle. This is a basic math or basic division. When they teach you, this is how they teach. You take an apple, cut into 3 pieces. 3 pieces you will get, 2 pieces I will give to him 1 piece. Same concept. Got it? So please mention that. You just mention a line that like it is 2 times positive cycles, positive pulse, not cycle, and 1 negative pulse. Or 2 by 3. Or 2 by 3. Or 2 by 3. 2 is on period in 3 of this. Is it clear? You write a program. Will you write a program for this? Will you be able to write a program for this? Right. Next one. We'll do one very, very interesting thing. I believe like this will be very useful for all of you in writing your self-study. So this delay was required, but anyway, we'll see that. What is this? Balaji. Stop it. Who will take the choppies from here, yeah? You should tell them not to take. You can tell, like, it is sir's property, like you should not touch. If they want to keep, they can keep it here, right? Why they will keep it there? Huh? They have booked it first. Okay, then we'll change the place. Right, guys, quickly. See to this, what we are doing is, in this, now we know. Listen. What is this? This is a, what is NOT gate? 00. 74 LS 04. 04 is a NOT gate, right? Huh. Why we require, guys, this is one more important point. Why we require a NOT gate or a buffer here? It is only because the current output from here, if it is not enough sufficient to drive this load, this is acts as a load now. This is what is this? This is a buzzer. It's a buzzer symbol for buzzer. It's a buzzer. If it is not enough, then we will use one buffer here. Buffer or NOT gate. Okay. What it does is, because it is connected to the VCC and the ground, it drives the current from there. It drives the current from there. So whatever the source current rating is, that is important for that. You are getting what I am saying? Right? Done. So we need to connect a buffer or a NOT gate in between the load and the pin only when this current is not enough to drive this. Point number one. Point number two, it is a safety circuit. This part of the microcontroller will become safe by connecting this. So it is a safety circuit, or like when it's the load. That is the point. Right. Now, we know how to on this buzzer now. Do you know how to on this buzzer? Same thing as an LED, but you have to reverse operation. If you set there, it will become off. If you clear there, it will become on. Because of NOT gate. If you get the buffer directly, then it is state. Because you have studied the 04, I have taken the 74 LS04, correct. NOT gate. That is why we have taken this, so it will be not operation. If it is 1 here, it will be off. It is 0 here, it will be on. Is it clear? Like this part. Now, coming to this side. What we want to do in here is, we have connected one switch and one pull-up resistor. So if I press this switch, this pin will get 0 value. When this pin will get 0 value, I want to turn on this buzzer. That is what is my requirement. Can you write a program for this? Did you got the requirement? Right. Here we have written this structure. Please write this structure and we'll write one statement. Write a program. Write a program to turn on a buzzer. To turn on a buzzer. To turn on a buzzer. When a switch is pressed. A switch is pressed. Switch is pressed. How do you do it? Now this delay we require, okay? I shouldn't have erased it, this part I have erased it. This delay, anyway, if there is no delay, the buzzer will beep with some microseconds, you will not be able to hear. Okay, so there has to be delay. There is no second option, there is no second doubt in that. Next. Set bit port 1.3. Do we require a delay here? After set bit, we don't require a delay. Next. I want your inputs. You understood the program? What to write? Tell me, how do I check whether the switch is pressed or not? How do I check it? That is what it is, 0. How do I check it in the program? Huh? No, J and Z is only for the A. No, there is one more option you have. J and B. Jump on bit, jump on no bit. This is what? This is bit addressable register. You can directly check the P1.3. Your solution is also right, but it is round off solution. But this solution is direct. What we have to do? We have to check this pin. If that pin is 0, then I have to do this on here. Clear? How do I check this pin? Using JB and JNB instructions are there. Jump on bit, jump on no bit. Okay? Then what I have to do? Yeah, this is very important. Guys, see here. This is important. No, this is also not important. Why it is required? Who said this? This is not important. Why it is required? Be the point. It will be one only, yaar. But I appreciate your honesty, which these guys don't have. See, he said at least. And who said it? Like he said, I said it. Whether it is right or wrong, he will decide later. But you should be honest. Only when you are honest, you will grow stronger. If you are not honest, you will go weaker. Okay? That is why. Good, yeah. Yeah, next. What I have to do? No, first what I should write? Jump on no bit. No bit means that bit is not set. Bit is clear. When jump on no bit, wait, what I have to do? Like for jump on no bit, port 1 third pin, comma, somewhere we will jump. We will say here for that also. No, we will say H1 for it. H1 is important. Now, like where will we jump? We will jump somewhere here. And what we have to do in that? When we jump somewhere, finding that this bit has become 0, what we have to do there? Set or clear? Clear P2.3, so that it will become 1. When it becomes 1, that means it is buzzer will go on. Okay? So what I have to do? Clear P2.3. This clear and set purely depends on how you connect the buzzer. If you connect the buzzer directly, then it should be set. If you connect the switch above, then it should be set or jump on bit here. It depends on how you connect it. You should know the electrical signal flow. Is it clear? Clear 2.3. Then buzzer will go on. Then what do you have to do? No. You should call delay. L call delay is must. L call delay is must. Then like S jump here. We have jumped back here. This time there is no button pressed. Sorry. Button is not pressed. Then that means it is pulled high. This becomes false. What should I do? Set bit. You should write. Always remember one thing. When you are writing a program, try to write a program for all possible conditions. If that arrives in your hardware, what it has to do, it should know. What is this? You are telling a logical story to a controller. See, if this is this, you do this. If this is this, you do this. That's all we are telling. Right? So set a bit P2.3. Do you want a delay here? Is the question again. If you give a delay, this set bit will, right? You have not pressed it. What it does, see here, there is one more thing. It will come here again. So it should not come here. We should jump this instruction. So what you do? Yes, jump here. There, okay, there. Where is there? There is here. Why should we jump here? We'll jump here only. Why there? We'll jump here only. You want there? You want to jump there? Let me know, yaar. You just